Hi, my name's Adrian Wright, and I'm CEO and founder of Estafet. I'm here with Antonio, and I'll let him introduce himself in a moment. But I'd just like to say thank you very much for listening this podcast. Estafet is a software delivery firm. We have experts across the software delivery lifecycle. We are particularly focused on Java applications. And in this topic, we're going to talk about the enterprise and a little bit about the transformation that's going on across their estate from legacy Java applications to agile, transformed, capable applications. And we're taking our experience from the enterprises we've worked with, Elsevier, Arqiva, WorldPay, HPC, Nationwide LNG, and some of the startups that we worked with as well, Pollinate and the Harbour, fantastic little startup companies. And for this particular podcast, we're going to dive quite deep into the developer realm, the realm of the developer. I've got Antonio with me here. Antonio, hi.
Hey Adrian.
Hi.
Hey everyone. I'm Antonio. I'm a software developer for Estafet. I've been with Estafet for 3 years. I'm based in Bulgaria. And in my free time, my passion is actually also software development. So I work on many side projects after work, before work, and pretty much all the time.
That's a lot of development, Antonio. And look, working in an area that you actually are passionate about, I think you're probably in one of a few percentage of people who really appreciate what they do. And it's great to have you on here. So before we dive down into some of the technical detail and talk at developer level, let's just position our conversation. We are talking to enterprise architects, to project managers, to developers who are really involved with transformation, with the interest in making that much more efficient and taking their applications and bringing them into the world of agility. So that's quick change, cheaper change, easy to integrate with, part of the process, as well as being resilient and secure. And obviously that's big across our industry at the moment. But let's talk about, Antonio, you are walking into a company and getting up to speed. Obviously, we partner with many different types of companies. That onboarding is really important to get you up to speed, because unless you understand the environment, obviously understanding the business requirement, but the environment you're in, then your efficiency begins to decline. And the challenge you have when you walk into an area with legacy Java code versus something that has a high quality and, let's say, is very stable and is very well documented. What's the difference for you when you onboard?
Well, onboarding into a legacy project that probably lack proper development, proper testing, your efficiency drops quite a lot. You need the assistance of a senior developer that has worked on it as a minimum. If you don't have that, you're going to spend a lot of time trying to understand the code base first, and afterwards trying to build on top of it.
Yeah, I agree. And actually, coming from a business angle, I see that in terms of high cost of onboarding, and actually the productivity of the team will slow when you onboard people, because you need to go to you need to rely on a senior developer in order to bring you up to speed, because the documentation or the quality isn't there.
Definitely. You're going to lose a lot of time. It's going to be hard to get yourself onboarded, to get other people onboarded. You can't rely on in most cases that's the case. You rely on a single person that has all the knowledge.
Yes, I agree with that. And this is interesting for me in terms of speed and efficiency, because we find that if we can get on board correctly in 2 weeks, obviously there's a massive cost saving because we're delivering in week 3, whilst some applications may take us 6 or 8 weeks to actually get up to speed fully and really understand that process. So cost-wise, if you multiply that out across a large team, then the drag on the existing team can be huge. And this is a really interesting discussion around scaling, but it comes back to quality. Let's dive down into quality, because there's a lot of changes going on here at the moment. I want to get your opinion on. Can you talk a little bit about when you walk in and you're looking at an application and getting up to speed, how unit regression testing is important to you, and those missing scenarios in particular? But just talk to me about testing and the quality of that code.
Yeah, so testing is obviously very important. One of the reasons being that, imagine you're jumping on a large code base. You have a mature large code base that is not properly tested. So this code base has multiple dependencies with other, when you run the service, it depends on other stuff, on other services, or databases and such. When you implement a new feature, you're going to have to spend a lot of time testing that feature properly if it is not covered. The thing is, if other features have not been previously covered by regression tests, there's no quick way for you to verify the functionality. You have to drift off and test other components. You need to test the whole ecosystem. You need to test end-to-end everything. And quickly, the testing becomes 3-4 times more than the development time.
And when is that testing done, Antonio? So just explain to me, in terms of that software development lifecycle, the sorts of testing and the efficiency of each of those.
Yeah, well, with unit testing, for example, the unit testing is done on a very, very early stage. It's during development.
Mm-hmm.
You write your code, and then you write unit tests in the traditional way to cover the functionality of your code. And with tools that are like DivBlue, for example, you can use their generation of unit regression tests to generate automatically, instead of the traditional way, tests for your code.
Mm-hmm.
And afterwards, after you implement a new feature, you can run the previous regression tests and confirm that your feature doesn't break anything. So unit tests are very early and are very important, but are often the ones that are overlooked and not properly implemented. We sacrifice time of unit testing to deliver quickly. That
Right.
happens.
Yeah, I understand. Can you just also talk to me about integration testing, just a minute as well?
Integration testing is it simulates a bigger part of the application. It's you can say it's after unit testing. So after you deliver, after you create your feature, you then create unit tests and you create integration tests. With integration tests, you test a bigger part, a bigger flow of your project. That's why they're very important, because they include multiple components during the flow.
Okay, no, that's great. And just briefly, before we get into some of the tooling, the role of the QA, particularly the QA with automated skills, where do they fit into your world as a developer? How do they help?
Well, QAs are very helpful at end-to-end testing. We can have multiple ways of testing. They can do a black box test without much details on the implementations. They can have a required behavior, and they can test according to it. This is very useful because QAs usually have another perspective on the product, on the functionality. And QAs can also be very helpful in a behavior style development with writing component tests. They can be very helpful at that because they can write component tests knowing what is the behavior of the service without needing to know what is the implementation.
And with a QA, let's say that you come into a development team and you're onboarding and you're working with either collaboratively with the customer or with Estafet, project management and delivering to a business requirement. When you see the QA, when would you like to see them in terms of your efficiency and your ability to deliver when would you like to see them in that software delivery cycle?
I would like to see the QAs very early in the development. It's very, very beneficial if the QAs are in the room at the first meeting, there with us. They need to know details. They need to ask questions. They need to be aware of the product.
Okay.
They need to know what's being developed.
So this is quite important from where I'm going in terms of we're now going to start talking about some of the tools that might help you in terms of that delivery cycle faced particularly with a legacy Java, a complex legacy Java application. We particularly looked at some of the AI tools recently, and I know you've done a little bit of research and investigation into some of the ones that are just literally onto the market. And can you just talk to me a little bit about the tools you've seen and the problems they're trying to solve?
Yeah, recently the market has been a lot of tools were introduced to the market. So I've touched some of them. Let's talk about, for example, the GitHub Copilot.
Yes.
Tools of such nature, they are AI assistants. They assist you during your writing of the code. So there's a tricky part here. They can be very helpful and very useful to the developer, but they can negatively impact the developer if he over relies on them too much. So the idea of these tools is to help you develop, not to replace you, not to do the thinking for you.
So just dive down a step below that. Just describe to me, you're sitting down, you are about to develop. How do those tools interact with you as you are developing?
With the case of GitHub Copilot, for example, you start writing code and it can autocomplete code for you. That's one of the things.
Okay.
Other thing is you can literally, like ChatGPT, you can ask a question in the text editor that you have open. You can ask a question and it can provide an example code block.
Yeah.
ChatGPT, obviously, it's almost the same. It's just you need to open a browser window. You need to navigate to their website. You need to ask the question there. With the GitHub Copilot, it's a little bit more integrated with what you're doing. It knows, it has context. It knows what you're doing.
Yes.
For ChatGPT, you need to provide context.
Yes, I understand. So both of these tools could autocomplete and the asking questions. They're just making you more efficient. In terms of the autocomplete, does that autocomplete just code, or is that autocomplete on unit tests as well?
It autocompletes on everything.
Okay.
No matter what kind of code it is. Yeah, you can also ask it to write a test for a block.
Okay.
It could generate from top to bottom a whole test case.
And so then you go back and check that. And do you find that is a good quality, or are you then spending time increasing the quality of that code or the unit tests?
I would say that's a bad quality. You shouldn't really be doing that. You're gonna spend time afterwards validating the generated code and looking for mistakes which could potentially increase your development time. In my opinion, this is the wrong way to use such tools.
Right. But I guess it would make you quite efficient in terms of delivering that code, but you're suggesting that it might not be at the quality you want, and you've got to go back, therefore, and enhance it or check it.
It might even deceive you. You will produce something, but that test, for example, will pass. Okay, but if you haven't checked it, it might not be correct. It might actually be testing, not testing hard enough. It might actually not be testing thoroughly enough. You might be missing test cases when you blindly follow the generated code block.
In the software delivery cycle, if you use that, if you use something like the autocomplete or the any sort of tool that helped you, when would if you like, low quality code, let's call it that, low quality code be caught out. So you would then, you've written the code, or the autocomplete has written it for you, you then submit. How would that code be caught out and thrown back to you?
Well, there are multiple scenarios in which that could happen. You could use automated tools for code checking. There are tools that go through your code and throw a hint at you if you've done something strange, if you're missing coverage, if you have a potential security vulnerability, and stuff like this. The other way is when the code comes back to bite you after a few weeks of being in production, a bug pops out, and you're starting to wonder what happened.
I understand. So you pick up, there's an important point in what you've said there. You're a developer, and whether you've written low quality code or you've written code that's full of bugs or it's just incorrect, and you submit that code, there's obviously there could then be a period of time before that is discovered and has come back to you. Either it's a discovered bug or it's a low quality piece of code. Tell me the difference in terms of your efficiency between the scenario where you spot that straight away as you write it, or a tool helps you spot that mistake or low quality or error, versus not discovering that until, say, right at the end of the software delivery cycle, maybe, which could be months later. Just talk to me about the difference for you.
Well, the cost of identifying a bug almost immediately, as you said, is nothing compared to finding it at a later stage in production in some months. The context switching that you have to do from your current tasks to something done months before is very it's time consuming. It's hard. It's hard to come back a few months ago, context switch to that, try and see what you did, try and see what you did wrong. Are the tests covering it? Why didn't they cover it? You're gonna spend you might spend sprints on a singular bug that could have been eliminated if you just used a little bit of help, for example, from an AI tool that can go through a code check, that can do a code check, security check, things like that.
Okay, I understand.
It can be very expensive.
And so just I know that you probably won't like answering this question, but if I spot a mistake when I'm actually developing the code, let's say that takes me 1 minute to fix. If I leave it for 2-3 months and it comes back, let's say integration testing or a go live, closer to go live, give me an idea of what I'm dealing with now in terms of your ability to get back up to speed, follow it, and then find and track change the error, correct the error.
Well, it really depends on the impact, on the change, on the scale of the change. But it could easily take you weeks. I mean, you can go with a full sprint from 1 minute to full sprint. It could be something small, but what if it's related to a lot of things?
Yeah, so that's a huge impact. That's
Huge.
That's massive. Okay, I understand that. That's great. Can we talk about AI and the impact it's had specifically around DiffBlue, because I know you've done some research on that, and we'll post a link to DiffBlue and some of the research papers that I know you've written in this area. But could you just talk to me a little bit about the impact of something like DiffBlue on the software delivery lifecycle and the work that you would do as a developer?
Certainly. Tools like generative tools like DiffBlue can have a massive impact on performance. The reason being that what they do is they auto-generate human-readable, almost 100% unit regression test coverage on your code base. So imagine you're in a large code base where During the initial development, it was a rapid development. You didn't have time to write tests properly and stuff like that. When you run the tool there, potential months, even I could say you can go to a year of time is saved, of development time is saved in just a few hours.
Wow.
So you can do a full coverage of the code base with these unit regression tests, plus tools such as that. While they are going through your code, they're also validating it for security holes, potential problems, some weird stuff that you may have written.
Yeah, I understand. So let's dig into the difference then between something like DiffBlue and the previous tools you've mentioned, where you were really looking at autocomplete or a sort of chat GPT aid, help mechanism. What's the difference?
Well, they're kind of different tool sets. With the GitHub Copilot, for example, it's an assistance tool. It helps you when you want it to help you, and it's just a lot smaller scale. DiffBlue is designed in such a way that you give it your whole code base, it goes through it, does all the checks, does all the validations, generates unit regression tests. And yeah, it's just a different kind of a solution, and it's at much larger scale. The good thing about that also is with legacy projects, the tool like DiffBlue can work with projects from Java 8 to Java 21. So you can basically revive uh, a legacy code base by filling it up with regression tests and using them afterwards when you develop new features for it.
And why is that important?
Well,
Particularly the Java upgrades and the increase in quality.
Well, the Java upgrade is, first of all, if possible, you should always upgrade your code base. You're missing out, and most of your dependencies are probably going to go out of support at some time. So it's going to get back to you. So focus on upgrading on code base. If you can't do that, with tools such as DiffBlue, you can run checks on your code base regularly to see if you have security holes, for example. You can, and when you create regression tests with tools like DiffBlue, you can use them as a basis for your next features. So when you create a new feature, you can use the generated snapshots from tools like DiffBlue to verify that you didn't break something, because sometimes it can be hard for a new developer to come into a legacy project because he's just not used to it. When you get a modern developer to go back to a legacy Java 8 project with older dependencies, older ways of thinking and developing, it can be hard for him, but the unit tests will be properly written with a tool like DiffBlue. They do a very good job. It's human readable.
I understand. So just tell me about the scenario. You come in, you sit down as a developer, and you've got DiffBlue or a similar tool, but DiffBlue is really sort of one of the leading ones at the moment. How does your work, your development change? Just describe to me what you do differently. If you had DiffBlue versus if you didn't have that with you.
Well, if I had DiffBlue, I would focus much less on the unit tests to manually generate them, to manually write them in the standard way.
Because DiffBlue is going to do that for you.
DiffBlue will do that for me, and I will just have a short glance at the generated tests to verify what they're testing and if they're testing it correctly.
Okay,
because they're human readable.
Okay, so it's saving you a lot of time in writing unit tests. Are the quality of those unit tests good, by the way?
Yes.
Okay.
It certainly is. They did a pretty good job there.
So you've got high confidence that your unit test is being written. So you're now generating unit tests, whilst before, if you're under pressure or any developer is under pressure, that might be something that they limit. Is that, by the way, 100% coverage? Is that the way diff blue
It's
works?
near 100% coverage. It's close to 100% coverage.
Why isn't it 100%? What's the issue?
I can't really say. It's probably a rough estimation from them, because some code paths couldn't be completely automated.
Okay,
But
understand.
that's not a bad thing. I mean, critical sections of your code should either way be manually tested.
Yes.
The test should be manually written. I mean, so if you have critical sections of code, you should take the time to test it properly.
Yes. Okay. I know that when we have delivered high quality code, often the percentages are sitting at 70 or 80% coverage for various, technical reasons, and also the way that metrics are measured, but that is still regarded as very high quality code. So yeah, I understand that. So it's creating your unit tests. What else? What's different then? You're therefore focusing your time on writing code because DiffBlue is helping you with unit tests. Tell me a little bit about what else happens.
Well, that's just one of the things. The other thing is that you're able to push out the new code confidently, because with the regression test generation that you had from previous runs, when you implement a new feature now, you can run all the previous tests to verify that the new feature did not break them.
Okay.
So when you have such a high coverage, you have very high confidence when you're developing it, and so you don't have to spend as much time testing it as you would normally.
Do you just give me an idea? And again, it's a horrible question to ask, but just give me a feel for the sort of efficiency you would get out of that. So if you were, if something was taking you, let's say, a whole sprint to develop, do you think with DiffBlue running those unit tests and how long do you think that would? Just give me an idea. I know it's very difficult, but give me an idea.
Yeah, that's a very difficult one. Well, depends on the functionality. Let's say that you have code for a mapper that takes some input and produces some output. So this is a good example of a unit of code that has to be thoroughly tested, because the input can be anything. The output has to be one thing. In such cases, you could save, I would confidently say, around 25 to 30% of time on that ticket of that feature.
Okay.
Something around those lines.
It's again significant, really significant.
It is
across, a large development team. Okay, that's interesting. And how about integration testing and the change to the software delivery lifecycle that a project using something like DiffBlue with its AI capabilities versus not having that tool available to you?
Well, it's still good for you to write integration tests for features that are not that critical. For simple features, you can actually skip integration testing if you go with DiffBlue regression tests.
Oh, why is that?
Well, because the generated tests are high quality, and you can they mock a lot of the functionality. You can just run those tests, and you won't need integration tests, because you can confirm with them that the functionality is all right, and with the previous set of.
Right, because you're making me nervous as soon as you say something like that. I don't need to do integration testing on this type of integration. So your confidence would be quite high that those are good quality integration tests.
Yes, but let's not forget, if it's a critical functionality, you need to not only have generated tests, you need to manually write tests and confirm.
Why won't why won't something like DiffBlue manually do that? Automate that for you?
It would. I mean, you will have tests for it. You will have generated tests, but the developer's perception is irreplaceable.
Right.
You must have a developer with common sense there, having a look at what's generated. You can't just take the generated code as is, because these tools cannot replace us. You
Right.
must have a developer there.
So if you're doing integration tests in that way with DiffBlue, what happens to the normal integration testing process or time that you've got later on, that you normally have later on in the project?
Well, you can save on that time for non-critical features. You can rely entirely on DiffBlue, and yeah.
So you're bringing forward, you're bringing up front to earlier stage those integration tests. You're still doing some integration testing, but it's really on critical features, and that's almost a retesting later on. Okay, I understand. That's interesting. Now, obviously, there's lots of other tools out there. Are there any other tools that you'd like to mention in particular that help you as a developer be more efficient?
Being more efficient. From the AI tools, I would say these are the main ones.
Okay.
GitHub Copilot is it's amazing.
Yeah.
Recently, JetBrains introduced a new one. I'm going to test it soon as well. It's integrated into the IDE.
Yeah. I guess we've also got the more, you might call them more traditional tools like Cucumber and other tools out there but you'd still be using those, would you?
Yes, of course. Cucumber solves a different problem. So yeah, let's talk about that a bit. So Cucumber is used to integrate behavior-driven development into your Java Spring projects. It's amazing because the way it works is you define feature files which are written in plain English. And these feature files in plain English describe the behavior of a component. So when they're written in that way, in plain English, everyone, all the stakeholders, can understand what this component is supposed to do, what are the steps it will undergo, and what's its behavior. So in that style, you could actually define the tickets for your tasks.
Yeah.
And when you have meetings and discussions with architects and all the stakeholders, they can all see in plain English what this component will do. You copy that, you put it into the feature file in the code, you write Cucumber component tests against it, and that way you have put a starting point for the feature. So the test will initially fail, but then the developer will start developing the feature, and the behavior will start working. The test will start to pass. This alone is a major time saver, because from my experience, we've had a few misunderstandings at later stages of feature development. Almost a few steps before release, we had to go back into the beginning and redo core functionality because we had slight misunderstandings with the architect.
Wow.
This can happen. Yeah, this can happen.
Yeah, I understand. So this would be a good time to just talk about some practical applications and examples around BDD and AI and the use of how you can make the SDLC efficient. Can you talk a little bit about one or two real life examples for me?
Yes, we've had actually a similar experience to what I described previously in one of my projects. So there was an issue where we had a slight misunderstanding, and we had to go back and redo a big portion of the core functionality. The way we solved that is a colleague that we have at SFA introduced that we follow a BDD style for the Jira tickets of the features.
Okay.
This was a game changer. When we introduced that, Immediately, at a first glance, all of the stakeholders could understand what this behavior must do and that's what it will do. That's what we will transfer into the code and work upon. So this eliminated entirely the issue with the misunderstandings and working on the wrong functionality for an entire sprint.
Fantastic. No, that's a great example. And if we can increase in communication then and clarify what we're doing and what our objectives are and how we do that, obviously with the architects at that stage, you're going to just continually get better efficiency out of the team, and that leads to productivity and that leads to lower costs. Interesting. Okay, thanks for that, Antonio. Just to sort of begin to wrap up, having done the research and having been in real live situations and had that experience, what sort of advice would you give for teams and developers in terms of the future really, and what's available to them and what they should be looking at in order to follow one of our basic principles, which is continual improvement? We all strive for that, and which is why through Scrum we adopt that methodology to look at what we've done and improve that. But what sort of advice would you give for teams about their improving their existing processes based on your research?
Yes, well, it depends on what the team is lacking, what are the issues on the particular team. But I would say the example with the BDD, with the behavior-driven development, with the Jira tickets, this, in my opinion, is a must, and teams should start adopting this strategy in the future and when defining tasks. They should spend the resources to try and learn how to use it, and they should just go ahead with an example. They should try to implement it with a smaller project, have a small team working on it, dedicate some of your time trying to adopt BDD.
And how do you, as bring in that change and bring in and assess tools to improve the efficiency of the team?
Well, one way you can do that is, for example, do you have some past experiences negative with lacking unit tests, for example, or lacking any regression tests? I can give an example here as well. We had, it wasn't very often, but from time to time, an issue would pop up because we were working with mappers. So we didn't properly unit test them, and let's say we get some a bit more malformed input, and immediately you get an issue. That issue can be anywhere in the 6 microservices, anywhere in the 3 databases. So with issues that you identify that could have been caught very early by unit tests, in these situations, you should consider adopting tools that generate regression tests for you.
Fantastic. Antonio, there's a lot of detail in what you've said, and it is extremely interesting, and I think this field is going to be developing very quickly. I personally think that the introduction of new tools will be quite prolific probably over the next couple of years in terms of not just Java development, but development in general. And we're beginning to see the impacts and how these tools can help us. You've obviously done some research on that, and you should keep us up to date with what's going on. But thank you for this. You've also written a couple of papers that are available. We'll put those in as links to the text on this podcast so that you can read those. And obviously, if you want to get in touch with either of us to discuss those issues further, then please do please again use the contact links that we put there. Very good. Antonio, thank you very much. I know it was a bit of a deep dive, and I know I asked you some difficult questions, but absolutely fantastic. Thanks very much.
Thank you, Adrian. Thank you for having me.
Okay, cheers now. Bye.
Cheers.